Okay, so we've got pyramids now. So you should have lesson 12.1. Today we're going to talk about different parts of pyramids. Would you grab the left line push one, please? One. Left, yeah, the left, there you go. Okay, so this is a pyramid floating around here in space. Okay, there's all kinds of different pyramids. Floating in space. Okay, and so notice the pyramids and back in. Okay. All right, so pyramids. Now look at the sides of the pyramids. What shape do you notice they are?
A pyramid.
Triangle. Triangle.
They're what? Triangle.
I don't know.
Okay.
Why they look like pyramids?
So we got triangles as the sides. Notice they're related to prisms, right? They kind of, I mean, looks like a prism with parts missing. So today we're going to talk about the parts of the different pyramids. Now, I've got some examples up here. We got triangular pyramids. So it doesn't just have to be a bottom that's a square. It could be a triangular. It could be rectangular. It could be pentagonal. Or it could be hexagonal. It could be octagonal. It could be dodecagonal. Right? We name prisms the same way. I'm sorry, pyramids the same way we name prisms. The name of the base tells us the name of the prism. Okay. So here are the different parts. We've got a base. Now notice the pyramids here only had one base, unlike a prism which has two bases, right? So it has one base, and the way you tell the shape of the base is it's the one that you can basically set it down flat on the table and it wouldn't tip over. The lateral faces, just like with the prism, it's the sides. But all the lateral faces were what shape again? Triangles. Unlike a prism where they're all parallelograms. Right? One other side note here, the number of lateral faces will always be equal to the number of sides of the polygon. Gotta think about why that might be. Another vocabulary word, apex. The apex is just another word for the top. So you've probably heard about like the apex of a mountain that reach the apex. That means the top. We sometimes call it the vertex, but we're gonna avoid that because the bottom of the pyramid, all those places where the lateral faces meet the base, those are all considered vertices as well. And so we're going to use the word apex to mean the very top. Okay. I've got lateral edges, base edges. The altitude, just like the altitude of a triangle, the altitude of a pyramid is the height of the pyramid. It's the distance from the apex straight down, so perpendicular to the base. The slant height is along the sides of our pyramid. So if I go back to my animation here, and I slow this down so I can talk about it. The height of the pyramid, we can't really see. If it's a solid pyramid, we can't see it. It'd be the distance from the apex straight down to the base. Again, we can't see. There's an imaginary line in there. The slant height we can see. That's the distance from the apex along one of the slanted sides here to the bottom. Okay. So the slant height we can see, the height if it's a solid pyramid we can't see.
No.
Okay. We name the pyramids based on the shape of their bases. And then when you see this word apothem, it's the same meaning of apothem, but when we say the apothem, we're talking about a pyramid, it's the apothem of the base. Okay, so the triangle sides all have apothems too, but we don't ever refer to those. It's always the apothem of the base. Okay. So I didn't erase this, let's erase. So I've got some arrows drawn here for the apex. The apex is the top, so draw that arrow. The altitude, again, just to be clear, is the line going from the apex straight to the base, to the center of the base. And then the slant height is going along one of the lateral faces from the apex to the base. One other side note, which isn't labeled here, but I'm going to go ahead and remind you of. This dashed line down here at the bottom is the apothem of the base. Because the height is going straight from the apex straight down to the center of the base, this distance from that to the edge will always be the apothem of the base. We're going to label some more. So the base, well, there's only one base in a pyramid, and that's going to be, that whatever that shape is. In this case, it's a rectangle. Why am I not calling it a square, by the way? Because a lot of you guys are not a square. Why is it not a square?
What? Oh.
Square is two-dimensional.
Do you see any congruency marks on here at all?
No.
So unless you're told it's a square in some way, you can't assume it's a square.
That
Okay.
kind of makes me mad. Like, it looks like a square, it should be a square.
Right.
It looks like a square.
Bring out the
It looks
ruler.
like a square. It might be a square.
Just go ahead.
Okay?
Get the ruler.
But we don't assume that it's a square unless either there's congruency marks or we're told this is a square prism.
Which one's the
Okay?
There's some on mine.
The tick marks?
The little line on the side.
Oh,
How was your day today?
Hmm?
How's your day today?
Fantastic, thank you. Okay, it's kind of like, imagine you go into, have you ever eaten at like a Chinese buffet?
oh yeah.
Oh.
And you go up and you're like, man, that looks just like spaghetti. And you get it, and you go and you sit down, and that was not spaghetti.
It was baby.
Right?
It was baby.
You gotta be careful. You look for the little labels on there. You go, oh, okay, okay, I'll go eat that, right? Oh no, that was some kind of squid dish with red pepper sauce, right? So that's the idea. It might be spaghetti,
Those baby
right? But
puppy
unless
brains.
there's something telling me that's spaghetti, I'm gonna ask, or I'm gonna go, I'm gonna shine. In this case, we're assuming it could be a square, but we don't call it a square unless we know for sure. Okay.
It was brains.
Moving on. That's a pretty good analogy. I'm happy with that. Base edge. So base edge, well, really, there's 4 base edges. I'm just going to label one of them, right? That's the edge of the base, but there's 4 of them going around. Lateral edge, again, there's a lot more, but I'm just going to label one of them. The lateral edge would be the side of one of the lateral faces, and there's 3 lateral edges per lateral face. This is a lateral face, the triangles. And then the slant height would be this line that's marked right here. That notice is the height of the triangle here, one of the lateral faces.
Example 1.
All right, so we're going to start by naming some of the parts of the pyramid. And notice it says name, not just identify, actually name them. So we're going to use our notation for naming. Now, what shape are the lateral faces one more time?
Triangles.
Triangles. So we're going to have 1, 2, 3, 4 triangles. That's going to be the names of our lateral faces. So we name triangles by drawing a small triangle and then using the vertices of the triangle. So E, B, C would be one of them. All right. That would be the one on the right. On the back, we would have triangle E, C, D.
E, B, C, D.
On the left, we would have triangle E, D, A. And then on the front, we have triangle EAB. Okay, so notice the lateral faces are the 4, or however many sides it has. They're always triangles. And we name the pyramid off of the shape of the base. So what's the shape of this base? A rectangle. So this is a rectangular pyramid.
This is people.
Okay. We're now going to name the lateral edges in the pyramid. So lateral edges would be these line segments that are connecting the apex to the base.
EB,
So we have EB.
EC,
So segment EB, right? Notice the segment. Segment EC.
segment ED,
Segment ED.
segment EA.
And segment EA. So these are all lateral edges, right? But really lateral edges are defined as the edges that the lateral faces include, I suppose. And so really we still have BC, right? That's part of that lateral face. So we have BC, we have DC, we have DA, and AB. Now, make a note down here by these 4. Those 4 are also part of the base. So these are also base. Okay, so So what are the basic names? Well, let's go here. So BC, CD, BA, and AB. Those are the base edge names. By the way, what would be the name of the base of the OC? So we can call it a rectangle, draw a rectangle, A, B, C, D would be a B, find this like that, it's this rectangular pyramid. So notice what we're looking for is this slant line right here. I'm going to label that S. That is part of the right. Let's draw that right triangle over here. So I know that this side over here. How long is this bottom right? This is the apothem. The apothem of this is regular. So we don't look for the apothem. But this is simply apothem. So our slant line, well, with right triangles, we have two possibilities. What are the two Those are the two options. You need to identify when you use it. You only use trig ratio angle besides trig ratio. We have to know another angle. Do we know another angle? So trig ratio is called we know two sides. Sure. So we use the trig ratio. So we have one day market. Last example. Let's find the height. So again, we've got this situation where it's a imaginary triangle here. We can go ahead and draw. I call it metric because it's not physically there. So we know this side is 22. We know this side is. And so again, we don't know any angles. So we also don't know any sides. So that means we either need to figure out an angle or we need to figure out a side. We might be able to figure out a side. So do we have any other information? And what changed? So what do we know about the thing? So we can get the side length of the side would be that divided by 4, 3 divided by 4, p squared. So that means that this length right here must be so our height is going to be the square root of. Now, are we going to be adding or subtracting? Are we subtracting? How? Why are we We're trying to find the side length, but because we know the hypotenuse. We know the hypotenuse, we subtract it, we look at the hypotenuse. We know the hypotenuse, we have 22 squared minus square root of 3 squared. Come on, how can you let me down?
Wait.
Yeah. And so 21.317, notice how close that is to the side. Right, this square root of 3 isn't very wide. This is a super tall. It's really small. Alright. Okay, so go ahead and take a look at the assignment really quick. So the first 6, you're just identifying parts. Number 7, finding slant height. I'm sorry, the height given the slant height. Number 8, pay attention to the special shape. It's a hexagonal pyramid. And you're given the pyramid, so the perimeter, so they call it that value. Number 11, you're going to need the distance formula. Write this down. Right. The distance is equal to the square root of x2 minus x1 squared. So the difference in x squared plus the difference of y squared. And number 12, suddenly there's an angle. All the time. And then number 13, I'll give you a hint. There's going to be 2 parts. You're going to basically have to find the apothem. And use the apothem. And this is a regular base. The bottom here isn't just a triangle. It's regular. And so then you may recall, if we draw this angle here is 30 degrees. So if we know the apothem, we can use go try to find the side length, and then use that to find the. That's it. Okay, so you should start with number 1, identifying stuff, and work through.
Number 8.